Okay, so what does simulation mean? What is a simulation? Lauren, what's a simulation?
Isn't it just like, I don't know, like you're simulating something that could happen or would happen?
Yeah, so you're kind of like, so if you're doing, let's say that you're gonna do the drinking coffee thing, right? Okay, drinking coffee thing, and so you go ahead and you're gonna take a survey of 100 and see how many people are gonna do that, right? So the point is that you just don't do one sample, right? You have the same population, and you can draw several different samples from that same population, right? So instead of doing that, we can simulate that in a computer, okay? And so that's what a simulation is, so that we don't have to do these many times, right? It becomes kind of tedious to have to do actually call people and find out how many people have drank coffee, right? So if you look at there, it says simulation is the imitation of the chance process based on a model that accurately reflects the situation. So how could I possibly set up this simulation of people drinking coffee, right? And we say that there's a 0.56% chance, 0.56 proportion that people are going to drink coffee that day. Okay, so how would you set that up? Okay, so the way you would set that up is that you would go ahead and you would, in your mind, think that, well, you would draw numbers, right? You go 0 to 55, and then from 56 to 99. So you assign the two-digit numbers, right, from 00 to 55 and 56 to 99, and you would say, if I get a number that looks like this, I'm going to say you drank coffee. If I get a number here, you did not drink coffee, okay? So you did not drink coffee, okay? And then I would go ahead and do a random integer generator from your calculator, right? And I would go from 0 to 99, and I would select 10 numbers, right? And it's going to spit out 10 numbers, or we're going to do 100 people, right? We're going to do 100, so we're going to spit out 100 numbers. So out of the 100 numbers, you would start counting, right? How many of those numbers are between 00 and 55? And so you would count those as being the coffee drinkers, and you could find out what percent of people in that random draw drank coffee, right? And once you're done counting it, you could hit that button again and you could run it again, and you ran another simulation basically, right? And you can do this many times, right? You can actually write a computer code that would go ahead and do that for you, right? In a computer, right? So that's what they mean by simulation. Okay, that's what they mean by, it says simulation is the imitation of chance behavior based on the model that accurately reflects the situation. Okay. So on page 305, there's a green box that says describe the simulation process. Okay, so describe how to use the chance device to imitate one trial. Okay, so you can do this. Also, you can do the same thing using the table D in the back, right? You can go, so we're gonna do the same thing, right? You're just drawing numbers. It's how you draw the numbers, right? So you can do that, right? And blah, blah, blah. So that's how you would use the simulation process, okay? So let's go ahead and look at the NASCAR cards and cereal boxes example. Go ahead and read that to yourself. I'm not going to sit here and read the whole thing, so go ahead and read it. This is on page 305. Good. So basically you have a cereal company that is doing a NASCAR promotion thing, and they're putting in random cards of the drivers in each of the boxes, and they're saying that each of them have, the equal chances of getting the drivers. And how many drivers are there? They are 1, 2, 3, 4, 5. There are 5 drivers, right? There are 5 drivers. So there are 5 drivers, and you want to somehow simulate, drawing a number. So how would you do this? How would you set the simulation up? So I would go 1 through 5 is the first guy, 6 through 10 is the second guy, 11 through 15 is the third, 16 through 20, 21 through 25, right? And the first guy was, I don't know who, Joey Logano, Kevin Harvick. And then you have Chase Elliott. Then you have Danica Patrick. And then you have Jimmy Johnson. Okay? So you would set the numbers up like this, and you would do a random integer from 1 to 25. And you would just go close it out like that and do one at a time, right? And then you would have to find out how many, or actually, you don't even have to do this, right? You can just call this guy 1, 2, 3, 4, 5, right? And you would go 1 between 1 and 5, and you would go ahead and press the button, right? Every time you press the button, you're gonna get a 1, or you're gonna get a 2, or you're gonna get a 3, or you're gonna get a 1, 2, 5. Anyway, so you keep on pressing this until you cross off every one of these guys, right? So because in order to get a set, if you want to get all 5 of them, you have to accumulate all 5 numbers, right? So you would do this, you would find out how long it takes for you to get 5 of them, right? So you did the simulation, so you do that, that's the way I would set the simulation up, okay? So we did that, and we did the dot plot there, and what do you have? Looks like you have a dot plot there with, I don't know, median number looks about 9 or 10-ish, somewhere around there, I guess. Okay. Explain what the dot 20 means. A dot on 20 means, what does that mean? It means that you had to press the random int generator button 20 times to get 1 through 5 and collect all of the numbers, right? And that's kind of rare, it looks like, because you're way out there. Okay. So C, use the results of the simulation to estimate the probability that it'll take 23 or more boxes to get a full set of cards. Oof, 23 is way out there, right? Okay, it's way out there, but what does that mean? It means that the odds of you taking 23 times is very, very low. In other words, this is statistically significant, right? It is significantly out of the norm. So in other words, this did not or could not have happened by chance. Meaning what? Meaning that the premise or the assumption that we made that all 5 of them have the same exact probability of showing up in your box is incorrect, right? So this is a case against that, right? Let's see what the book says on number 3. Okay, the probability is 0. So there's about a 0% chance that it would take 23 or more boxes to get a full set. Because it is so unlikely that it would take 23 or more boxes to get a full set, the result provides convincing evidence that the 5 NASCAR drivers' cars are not equally likely to appear in each box of the cereal, okay? So exactly what we said there, all right? So we're gonna skip the golden ticket parking lottery and okay, we are done. So we are done with 5.1. So let's go ahead